stream and you should see the video. So let's cover this up. Let's go over here. Okay, start with reciprocal identity. Everybody should know the reciprocal identities. What is sine theta equal to? 1 over what? 1 over cosecant? Good. Hold on. I think write it wrong. 1 over cosecant theta. Okay, must write down theta. Theta is argument. You cannot skip the theta. Some people just write down 1 over cosecant. That's not right. And I'll mark it wrong on the test. 1 over Leah, what's cosine? No. Michaela, what's cosine? 1 over what? Good. Tangent is 1 over what? Omni? Oh, Matthew, sorry. Good. Ava, what's cosecant theta? Good. You did great under pressure, huh? You didn't know, but you figured out right in the last seconds.
No, I did the whole time. Just didn't.
Okay. I like the confidence. Secant, Laura, 1 over what? 1 over cosine. Okay. Cotan is 1 over what? Edison? Good. Okay, what's the difference between quotient identity and the reciprocal identity for 10 theta? Quotient identity is going to be in terms of sine and cosines. Okay, so Amara, what's tangent equal to? Sine theta over cosine theta. You must write down the argument. If you don't write down the argument, I'm going to mark it wrong. Because it usually comes with something, sine of something. Hannah, what's cotangent theta equal to? Yep. Pythagorean identity. Now, a lot of people don't know that. Does anybody know what's Pythagorean identity for trig? Raise your hand if you do. Austin, got it. Okay. Now, Leah got it. Okay, 2. Any other student? That's not good. Okay, we'll start from the beginning. The beginning is a right triangle. And it has a theta. It has a right triangle. This is A, this is B, this is C. Pythagorean identity is A squared plus B squared is equal to C squared. We know this, but this is not trigonometry. We're going to take this A squared and we're going to divide it by C squared. Why? Because if I take it A squared plus B squared equal to C squared and I divide it by C squared on all of them, coincidentally on the right hand side we're going to get 1. This is going to be A over C to the square plus B over C. Am I going too fast? Now A is also known as what kind of size A? SOHCAHTOA will be the, what size A? Opposite, good. Why is it opposite? Because it's opposite from an angle. B is called adjacent because it's next to adjacent, next to the theta. C is the hypotenuse because C is facing 90 degrees. Am I going too fast? So can I write down as opposite over hypotenuse squared plus adjacent over hypotenuse square is equal to 1. What is the opposite over hypotenuse? Sine. Now some people knows like in my class I don't write it like this. I never write it as sine theta parentheses square because that's a lot of writing. The more appropriate way to write it is sine squared theta plus cosine squared theta is equal to 1. So that becomes the first identity, sine square. It's not 2. Some people say sine 2 theta. No. It's sine square, cosine square theta is equal to 1. Now, I would tell you this, a lot of misconception also does. Sine theta square, you can rewrite as sine square theta, but you cannot rewrite as sine theta square. The last part, it doesn't make sense because last one is only theta squared, not a sine. So order operation, you gotta pay attention. So the last part does not equal to each other. These two are equal to each other. Now, I do prefer this one because that's a proper way to write it. You don't have to write extra parentheses. Questions? Now, what I'm going to do is I'm going to go to sine square. Theta plus cosine squared theta. I rewrite this one because I want to derive the other two. So how do I derive it? I divided everything by cosine squared theta. And I'm going to use reciprocal and quotient identity to figure out the rest. So the next one is going to be, what is sine over cosine again? Tangent squared theta plus 1 equal to secant squared theta. Is that okay? Now you realize I write down theta there. If I don't write down 10 squared plus 1 equal to secant squared. I do write down theta because theta is an argument. Same idea, instead of dividing by cosine, I'm going to divide it by sine. So I'm going to divide it by sine. And that's going to be 1 plus cotangent squared theta is equal to cosecant squared theta. And that becomes a 2 identity that I need to know. Now, I do like this identity a lot because that's the first thing you need to know. But also this identity can change to 2 extension. The extension can help you convert from one trig function to another trig function. So if I just move the other side, and if I say move this to the other side, this is the extension. We use it later, but however, some people write this into the second and third is wrong. This is the right thing to write. It's the first one here. Second one here. Third one here. So those are identity. Now, should you write me the proof? Yes, you should write me a proof. You don't need this proof. This proof is not needed. So this part is not needed, but I'm still going to show you. I think it's important you know where the things come from. Now, sine squared theta is equal to 1 minus cosine squared theta. Cosine squared theta is equal to 1 minus sine squared theta. They are not Pythagorean identity. I write it down for future use. We use double angle identity and stuff like that. Am I going too fast? No? Okay. So Ken Chinoli did teach this. Okay. At first you guys told me you never heard it before. It scares me. Now the sum and difference, this part is might not teach or might teach. I don't know. You can tell me in a second. But I'm going to teach it a little bit different. I'm going to tell you there's an acronym for this. Why? One is SMS instead of XSOS, like getting help, is SMS, right? And the other one's CSO. So CSO. So there's 2 acronym for this. And I'm going to talk about the first one. SMS. What is SMS? So this one I'm going to write down. This is sine, mixed group, same sign. And that's how you're thinking about it. So how do I do sine? Well, sine start with sine a plus b, a minus b. How do I do mixed group? Mixed group is mixed between sine and cosine, and you want to completely mix even the order. So this one's gonna be sine, cosine, and then the second part is gonna be cosine, sine. And this, just write down a, b, a, b, and this is plus. And you got a first sum and difference formula. Questions? I just follow the acronym. But make sure cosine and sine switch places as well, because you want a cosine of a rather than sine of a on the second part. I'm going to do the second one. Again, I'm going to do a mixed group again. Sine, cosine, cosine, sine. And I'm just going to fill in a, b, and the minus. And that's enough. That's SMS. CSO. CSO. You can imagine what I stand for. C stands for cosine. Right, cosine. And this is going to be the same group because, and this is going to be opposite sign. Now, if the same group, do I start with sine and cosine? Well, since the thing is a cosine, so it's going to be cosine. So I'm going to start with a cosine, cosine, because the same group, sine, sine. And this is A, B, A, B. I always do A, B, A, B. Now this is going to be opposite sign because start with plus sign is going to be negative sign. Cosine of A minus B. I'm going to write down cosine, cosine. Sine, sine again. And I write down A, B, and this is plus. And that's it, I'm done. Sum and difference stuff. Fairly easy. Now, how many of you guys know what a sine of 2 theta is? Look, what is sine of 2 theta? You just memorize it? Which teacher you have? Okay, good. So Ali did a good job. Did anybody from Ali remember that? You did? Good. Okay, so that means you guys all did good. But do you guys know where they come from? Just memorize it, right? Okay, so I'm gonna teach you how to come from. It's coming from sum and difference. It's actually not a hard. So if I know sum and difference, I know double angle identity very well. So imagine that you have a sine. Rather than a plus b, I'm gonna say theta plus theta. Because of one angle adding to another angle. But what if those two angles are the same? So then I just use the sum and difference. Again, I'm gonna use the sum and difference. So sine, cosine, right? Cosine, sine, again. Instead of A and B, I'm just gonna place theta on all of them. I'm gonna add them together. Now, do you see that this just different order, but they are multiplication? So I can switch the sine, cosine, cosine, sine. Does that make sense? So this one is going to be 2 sine theta, cosine theta. Now, if you from Ali, do you remember what's double angle identity for cosine squared theta? Do you have that memorized? Okay, then I want you to think about this logic again, see if that's true. Look, what'd you say? What is it? Is that easy? Just derive it, right? Because you basically replace this as theta, 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 theta. Then that should be cosine squared minus sine squared. Does that make sense? So it's not sine squared minus cosine. So you just memorize, you don't understand. If you derive it, you understand, oh, this is not memorizing. Trust me, by next year, I don't know who you are. But I still have all the formula memorized. I just really bad with names. Except Ava's brother. Okay, so that is becomes the first double angle identity. But there was two equal sign. That means there's two more. And you're like, wait, what are the other two? The other two is also derived as well. So we're gonna use this formula to derive it. We're gonna use this formula to derive it. So we're gonna derive it on this side, okay? So it'll be cosine 2 theta equal to cosine squared theta minus sine squared theta. And we're gonna use this here and here because we can convert cosine to in terms of sine. This is very useful tools. So now I'm gonna take this, I'm gonna say it right here. I'm gonna replace that cosine square. So this one is gonna be 1 minus sine squared theta minus sine squared theta, and that's equal to cosine 2 theta. And with that being said, that's gonna be cosine 2 theta is equal to 1 minus 2 sine squared theta. So that's 1 minus 2 sine squared theta. I just replaced the cosine with this 1 minus sine. Pretty cool. I just come up with another one. So cosine 2 theta, I come up with the second one. I'm gonna rewrite again, same thing. I'm gonna say cosine 2 theta is equal to cosine squared theta minus sine squared theta. Now this time, I'm not gonna replace the cosine square. I'm gonna replace the sine square. What is sine square? 1 minus cosine. So it'll be cosine squared theta minus, now this one I'm gonna replace as 1 minus cosine squared theta. Now remember they are distributing. And this becomes equal to 2 cosine squared theta minus 1. So it'll be 2 cosine squared theta minus 1. And that becomes the cosine 2 theta, the second version. Now, why did I write this in black? Because those two things gonna lead to the next one. Everything are interconnected. So I never memorize just one identity. I memorize all the identity because I know the connection between one identity to another. Now I'm going to go to sine squared theta. And you say, okay, how do I derive it? I'm going to use this 2 to derive this. Why? Pay attention. If I evaluate for sine squared theta, or if I evaluate for cosine squared theta, I'm going to get a power reducing. But this is a very powerful. So I'm going to start with that. I'm going to start with the cosine 2 theta is equal to 1 minus 2 sine squared theta. And I'm going to just evaluate this. So for me, like I'm going to move the sine squared to the other side. Plus cosine 2 theta equal to 1. And I'm going to do 2 sine squared theta equal to 1 minus cosine 2 theta. I'm going to divide by 2 on all of them. So that's going to be sine squared is going to be 1 minus cosine of 2 theta. Now it's big 2, now it's small 2 over 2. So that's the first one. Second one. cosine 2 theta equal to 2 cosine square theta minus 1. So I'm going to add 1 to the other side because I'm trying to evaluate for this. So it will be 2 cosine square theta equal to 1 plus cosine 2 theta. And divided by 2. That's 1 plus cosine of 2 theta over 2. So this is a quarter of the test if you know your identities. That's 25 points. Yes, Gia. How much time I have? 14? Okay. Can I move on or no? Here. Unit circle. I don't want you to jump into writing stuff. I have a specific way. Not the same way that you look up on TikTok video. They tell you it's a shortcut to memorize the unit circles. I don't want that because I want that you understand the unit circle rather than just memorize it. I want you where you can teach your grandkids how to understand unit circle. So that means you're 40 years later and you still understand it. So let's do that. Today we only have enough time to do degree and radians. We don't have the time to do the rest of them, but we're gonna talk about next one. So I'm gonna start with I'm gonna use different color notation because the coloring is actually important. So okay. So this one is gonna give you a 0 degree. This one is gonna give you 180, and this is 360, and this is 90, and this is 270. I know most of you guys know this, so I'm not gonna spend too much time on it. Now the next one is gonna be I use blue. You can use any other color. But the reason why there's a color, I'm gonna explain to you why do I have three different color here. This is a 45 degrees. You know the opening from here to here is 45, but you know the opening from here to here is also 45. So therefore that makes 180 minus 45 is gonna be what is it? 135, good. So this is 135. And this is a 225 because adding 45 from 180, very, very important if you not notice that. And this is 315 degrees. So that is all the degrees. Now I'm going to go with red. This is 30. Why is that 30? Well, think about it. In an hour, in a day, there's 360 degrees because there's 12, in like 12-hour time in the clock. There's 12 section of each hour, right? Of a day, of a half a day. Now, if a circle is 360 degrees divided by 12, then that's going to be 30 degrees. So that means each clock movement for each hour, that's going to be 30 degrees. So this is going to be from 3 o'clock to 2 o'clock, that's going to be 30 degrees. Also, from 9 o'clock to 10 o'clock, it's also 30 degrees, but it's going backwards, so it's going to be 150. And this is 210, and this is 330. Question about here. Now I'm going to go with 60 degree, which is 2-hour period, so it's 60. 120, 120. Oops, sorry, not 120. Sorry, my bad. This is completely wrong. This one is 240. And this one is 300. Any question about this thing here? Now I color code them. Does anybody know why I color code them? No. Okay, do you guys remember something called reference angle? Your teacher will talk about reference angle. Doesn't matter, Kent or Ollie should talk about reference angle. Does Ollie talk about reference angle? What? Maybe? Okay. A reference angle is the angle from your terminal size to the closest x-axis. So in this case, this here is a 30 degrees. But 150 degrees is from here to here, to closest x-axis. That opening is called reference angle. So 150 has same reference angle as 30, has same reference angle as 210, because this from here to here, that's also 30. From here to here is also 30. So all the red one has the same reference angle. That's why their x, y value is exactly the same. Because they are exactly the same reference to the first quadrant, except different sign. Now, that's why I color code them. Now go back to the next one. The next one here is 45 degrees, so I'm going to use blue. What is 45 degrees in terms of radians? Yeah?
Pi over 4.
Pi over 4. If you don't know, there's two things that you can convert. 180 degrees equal to pi radian. That makes this, you have a 2 conversion ratio. I love this because this is a good SAT questions. Sometimes SAT question just asks you convert degree to radian, radian to degrees, and you have to use the right one. So if you start with a 45 degrees, guess what? That's going to be, you want to choose the one that had degrees on the bottom. Because if you choose a pi radian, nothing can simplify. So it's pi radian. Hopefully you did this last year. And this will simplify. This is a 4, this is a 1. So it's pi over 4. That's how you get that. So now also 180 degrees here. I like 180 degree here is known as, oh, sorry, I didn't do the pi yet. So this one is going to be pi. This one's going to be 2 pi. This one's going to be pi over 2 because half. And this is 3 pi over 2. Now there's a reason why they have 3 pi over 2. So I want you to notice something that's very, very important. I'm going to use purple here. Pi is equal to 2 pi over 2 is equal to 3 pi over 3 is equal to 4 pi over 4 is equal to 6 pi over 6. It could be 7 pi over 7, 8 pi over 8. Just know it's the same number is equal to pi. Also 2 pi is also equal to 4 pi over 2, just double them. 6 pi over 3, that's equal to 8 pi over 4, that's equal to 12 pi over 6. And knowing that is going to help you even if you want to find, say, finding sine of 19 pi over 6. You know 19 pi's go through 12 pi. That's one cycle already. So 19 subtract 12 is 7 pi over 6. So 19 pi over 6 is same as 7 pi over 6. It's going to 1 extra revolutions. Now, this is a very good thinking about things. What time we get off? Huh? 7 minutes. Okay, 7 minutes. Okay, that's fine. Pi over 4. So what do you think this one is? Beth? What do you think this one is? Is it Beth, right? Not sure. Ava? What is it?
4 pi over 4.
Close though. Oh, I'll let Ava figure out. I believe she's clutch. 4 pi over 4 is right here.
Yeah. 2 pi over 13.
No. Oh, I think I see what you did. That's not good. That part is not good. Gia, 3 pi over 4. Just basically subtract. Sorry, just subtract. This is blue. This is 3 pi over 4. I'm gonna ask you again, Ava. What's this one?
2 pi.
Oh no, let's keep on going higher. Yeah, because we're going 4 pi over 4, we adding pi over 4. Yeah, so 5 pi over 4. Okay, now you got an idea. Okay, what will be this one? Anna? Good. Okay, so now will be this one here. Area? 5 over 6, good. But this is in red, so it's 5 over 6. Will be this one here. That's Laura. Maybe Liana can help you. 5 pi over what? You're right. 5 pi over what? Keep on going. Don't guess. Don't guess. 5 pi over 6. Do you see this is pi over 6? This is the same opening. Go back to here. You subtract from 6 pi over 6. So it's 5 pi over 6. I'll give you one more chance. She's like, no, don't give me one more chance. I don't want to answer this question anymore. What will be here?
You said you add
Hmm?
pi over 4.
Is it pi over 4? What is the opening from here to here? This is the same reference angle. Ava, you want to help her out? There you go. You basically just add pi over 6 to here. 6 pi over 6. Okay, Laura, I'm going to give you one more chance. Over what? 11 pi over what? Over 6. Good. So now you know all the reference angle. All the red one has a pi over 6. First quadrant. Now let's go with another one. Last part. This one is gonna be 60 degrees. What? Maya? Pi over 3, right? So what will be here? Oh, sorry, that's in green. Green. Pi over 3. Leah will be here. 2 pi over 3. And what will be here? Edison. 4 pi over 3. Okay. 4 pi over 3. Last part will be here. 5 pi over 3. Okay. So we know all the radians. Now we're gonna go back to figure out this, but we're gonna figure out some easy one. This one's 1, 0, so this unit circle looks really big, but on regular graphing paper is about this big. 1, 1, 1, 1. So here is actually 2, 2. But the unit circle is this big. It just looks really big. We just magnify it. Okay. So if this is 1, 0, what do you think this is? 0, 1. Will be this. -1, 0. And 0, -1. Now we're going to talk about the rest of them, but we're going to talk about also SAT topic, which is 30, 60, 90 triangle and 45, 45, 90 triangle. And that's it, because we cannot go further. We don't have enough time. Huh? Yeah, there was a grading paper next today. So we're gonna go through the grading